Hi everyone, you are welcome to today's class. So today we're going to be looking at introductions to data analysis. So I'll be presenting on the value in statistics and data, what statistics and data is all about, how industries, businesses, governments of different countries, different spheres of human endeavor make use of data for evidence generation, decision making, and forecasting. So all of these are going to be dissected during this presentation. So if you have any question, kindly drop your question into chat box, and we'll definitely reach out or reply your questions. So what is the value in statistics and data? Well, these are very important questions because um, when the value of something is unknown, abuse is inevitable, right? Yeah, so the value in statistics and data, it's actually in what we make of them to me. And I've always kind of made this known to people around me that it's more of the usage of the data and the analysis of such data that brings out the value in the data. So that means that two people can actually have access to the same data, but bring out different information, different insights, and different results. So it's very important for us to know that it's actually the usage and the usage of the data and how the user of the data actually wants to use the data that actually drive the value in the data and statistics that drive the data analysis. So what is statistics? So statistics is just basically the science of learning from data. So major thing in this training is data. And we talk about data, so we generate data from the process. So the process can be perhaps revenue and sales or health outcomes, probably people going for checkups, the doctor's office, and their BP was measured at every point in time. This process this information over time will generate, will become data that we can then use to, understand the process of seeing that doctor. Also, perhaps maybe I own a farm, and on this farm we have different products, produce that we plant, and at some point I want to understand how much tons of particular produce we yield, like the farm yields from perhaps 10 years from now until today. So I want to understand that process. So I start to collect data, like the data we've collected, so I bring them together so as to generate information. So first into the science of learning from the data that I've collected. That's what statistics is all about. Statistics gives us the science, data gives us the information, and we are able to, data gives us the information in raw form, and statistics gives us the science to be able to learn from that data and drive or bring out information from that data. So also the value in statistics and data is that they help us summarize information from our data, spot patterns, and make decisions. So when we are uncertain about things, when we are certain about certain phenomena, so collecting data from that process allows us to summarize information around that process, spot patterns, then make decisions. So because in uncertain situations, we are usually not able to, like, or we are usually dumbfounded about how best to make good decisions. And data, or having access to data, actually helps us to summarize whatever information we have about that process and generate good decision that would help us improve that process or understand that process in the long run. And it's important to note that the use of data, transcends into different spheres of human endeavor, be it healthcare, sports, industry, different kind of industries, sports industry, agricultural industry, retail, FMCG, healthcare, different kind of industry. So data is used everywhere, especially now that we're now looking at data-driven decision making in the world, where we now want to have customer-driven decision making, data-driven decision making. All of these are driven by the data that we collect from those processes. And lastly, the value in statistics and data is in how we're able to turn on certain situations into insight and information. Because, like I have said, when we have a process that is going on over time, or that we know that we want to understand how this process works. When we generate data from that process, we're able to understand how the process works. We're able to know current situation of the process, the current state of the process, how the process is developing, evolving, and we might also be able to make forecasts, predict that process. So that's all about what value that we derive from statistics and data. And the next thing I want to touch base on are the core principles of statistics, because these core principles are actually what we are going to be adopting when we want to drive those values that I have mentioned that we get from data. To get the value from data, we make use of discrete statistics to describe the process. So with discrete statistics, like something like bar chart, which we are going to talk about, bar chart, pie charts, different kind of charts, tables. All of this allows us to be able, all of this allow us to describe processes, describe systems, and describing them helps us understand, okay, this is their state, this is how they are. So a step after that is inferential. So inferential statistics helps us to, make generalization, make decisions about what we have described. So description is the first process, then inferential is the second process. So now we have known the state. I want to, okay, can we generalize? Can we predict? Can we forecast? Can we study relationships? So going this step forward is where inferential statistics sits. And to be able to make use of inferential statistics, we have to understand the concept of probability. So probability that an event will occur, probability that an event will not occur, probability of an event given another event. So all of this helps us to make use of our inferential statistics to generate conclusions, generate insights from our processes. Other principles are estimation, which are also linked to inferential statistics, hypothesis testing, which are also linked to inferential statistics, and sampling, which are also linked to inferential statistics. So estimation is the process of getting an estimate from our processes. So instead of describing, we want to be able to get some information that describe the system, some information that helps us generalize the processes. Because in reality, we won't be able to get data from all of the processes. So we have to sample. And when we sample, we get estimate from that sample. And from that estimate, we're able to understand what is going on in the process. So all of these are core principles of statistics, which we are going to discuss as we move on in training. So like I said, this is just an introductory class, which we're going to continue to discuss, continue to look into as we move on in this training. So why data? Why do we collect data? Why are we taking our time to even collect data? First thing is we want to generate insight and information from processes. So that's the first objective of data gathering, or objective of collecting data about a process or from a process. Because we want to understand the process, we are uncertain about how the process evolves over time, how the process moves. And because we're uncertain, we don't have that information, we want to collect data from that process to be able to generate insight from that process. So that's the first objective of data gathering. collecting data. So second objective, which is like another step forward from insight and information, is decision and policy. When we get information, what does that information mean? Then it drives our decision making. When we're able to understand what a process looks like, then say, okay, this is what we can do for the process, this is what we can do, this is what we cannot do, this is what we should do, this is what we should not do. All of this then spills into policy making, development of policies and also generating information also, help us in planning, because when we understand the process, we can plan better, we can, prepare and plan effectively. Also, it helps us in estimating what can happen and what cannot happen. It also helps us in forecasting. It also helps us in modeling. So now we talk about AI, we talk about machine learning, we talk about data science. All of these are heavily linked to modeling. We'll see forecasts, we'll see predictions. All of these are heavily loaded with modeling, and modeling is just the higher level of information generation from data. So modeling allows us to be able to see what are the interrelationships, relationships, association between variables that are in our data sets. So what modeling is one of the major objectives of data gathering, because collected our data, we can say, okay, for my data, how does X relate to Y? It's just like we are looking at, so I have collected price, I've collected data price. So I've collected data price of products, collected revenue from products, and I've collected all of this in different locations. So with descriptive statistics, I can know the kind of the average price of a particular product in a particular store. Then when I multiply the price of each product times the quantity of each product that was sold, then I can get my revenue. In revenue, I can get total revenue, average revenue per day, average revenue per month, average revenue per year. Then I can then look at, okay, different locations. In location A, what does all of this information look like? Price of product, revenue, total, average, sum, mean, standard deviation. So I can look at location B. I can look at the price of those products, revenue of those products. Then location C. Then I can now look at, okay, how does location A, these prices in location A, how do they differ from location B? You can see that I am moving up from just looking at price and revenue only, or the summary or describing them. I'm now looking at, okay, how does A differ from location B? How does the prices differ between the three locations? In that regard, I can now know, oh, in location B, it seems my revenue is high, then why? Oh, in location B, there are high number of middle class workers, employees. And I can say, okay, in location B, I want to stock more products. Then that has spilled into decisions. Then it spills into planning, because I can now then say, okay, I want to increase the number of products that I ship to this location B. If location B is driving more revenue, then I can estimate that, okay, in the next 1 year, how much would I generate from location B? I can then look at, okay, forecasts. In the next 5 years, how much am I going to make from location B? Then I can then model that, okay, what is the relationship between revenues and the locations? So you can see how the whole process spill into one another and make everything beautiful. So that's just the whole essence of the whole objective of data gathering. The next thing we want to talk about is sources of data. So the major sources of data are primary sources and secondary sources. When we talk about primary sources, we're talking about the usage and the way the data is collected. So when we talk about, okay, this is source of data, so it's talking about where the data is collected. So when the data is collected for a particular purpose, and I am using it for another purpose, and I say that is a secondary source of data. But if the data is collected for a particular process by me, and I'm using it for that same process, then that's the primary source of data. So that's the major differences between primary sources of data and secondary sources of data. So it's more of the usage of the data itself and how data is collected. So look at, okay, I want to study a process, perhaps the number of inpatients in hospital. So if I'm going to the hospital myself to collect the data, then that's a primary source of data. So I'm collecting it myself, I'm using it for that purpose. But if when patient comes in, they fill in their data with the doctor, with the healthcare practitioners, healthcare professionals, they put their data there. And I am coming to them, to the hospital, to use the data that has been collected from the patient. Then that's a secondary source of data. So we're going to be stopping this video here so that we can split the video into sections and we can take our time to watch different parts of the videos. Thank you. Kindly look out for the part 2.